Hello, hello. Today I will be walking you through, from start to finish, how to download some remote sensing data and map recently burned areas in the Palisades and Eaton fires and report out on which watersheds around Los Angeles have the most highly burned areas and severely burned areas, and make some charts. So let's get started. I am going to open up QGIS, and I'm also going to download the data from Canvas while that gets going. Now, I will note really quickly that I'm on a Mac computer, but you should be able to follow these same steps on a Windows machine. And I'm going to use QGIS today, but there's another tutorial coming soon in which we'll use ArcGIS to show the exact same process or a very similar process. So I just downloaded some of our data from Canvas, the huc10 watersheds.gpkg file and the landsat.zip folder. I am first going to unzip the landsat.zip folder. I've navigated to my downloads directory where I downloaded it. I'm going to right click and click Open with Archive Utility. It created a folder which contains the Landsat files that we need. Now we don't need these aux.xml ones, so I'm just going to go ahead and delete them really quick. You will see that we have our Landsat files, we have our watersheds files, we're all good to go. So moving back over to QGIS, let's just pretend that we've lost most of the relevant information that we need. The layers panel, the browser panel, we could always get that back by going to View, Panels, Browser, and we can actually move that around or dock it to various parts by shifting it and waiting for the screen to become gray like that. We can also get our layers panel in the same way. View, Panels, Layers. Great. So in the browser panel, let's load the data that we just downloaded. I am going to navigate to the downloads directory where I saved those files. There it is. You'll see I have many downloads. I am looking for a folder called Landsat. There we go. I am loading the Landsat data into QGIS, and there we go. We've got some images. Now I also know I need the LA watersheds file. I think it is called something like LA huc10 watersheds.gpkg. We get this warning message around transformations and coordinate systems. It's telling us that it will convert this from a geographic coordinate system to a projected coordinate system. In fact, UTM zone 11 north. We are very fine with this. We can click OK and safely proceed. Now you will see that our various data sets that we're interested in have been added to our layers panel. We can collapse the color bars by clicking on these down arrows. And we can put the watersheds on top of the images by clicking and dragging that to the top or dragging the other layers underneath them, and voila, here you go. Let's say you would like to add a base map to this project. Well, we can do that by going to Plugins, Manage and Install Plugins. Make sure the Quick Map Services plugin is available and installed. You can click Reinstall or Install if it's not. You can click Close. Now, to search for some base maps, click this little globe with the search magnifying glass right here, search QMS, and you can search for satellite. And once you do, several available data sources will pop up, and feel free to just select one. I like Esri and Google, so I'm going to pick this Esri one. And you'll see a base map gets added to our project. Great. We don't really need QMS, Quick Map Services anymore, so I'm going to X out of it. Okay, so what do we have here? We've got some watersheds, we've got some satellite images. What we want to do is calculate the normalized burn ratio. And what that is essentially a way of using two satellite images, one of the near infrared wavelength and one of the shortwave infrared wavelength, to map areas that we can then use in a change detection algorithm to figure out changes in vegetation cover, pre and post fire, where burning is likely to have occurred. If you want to learn more about this, we can just search normalized burn ratio and read about this on the USGS or on other sources. There's lots of helpful information here, including the equation. So the way we calculate this is the near infrared band minus the shortwave infrared band over the near infrared band plus the shortwave infrared band. Now, each of those different wavelengths or bands are given by these two different file names. So you'll notice some other helpful information in there. There's the date, 2025, January 6th. This is the near infrared channel. Similarly, this is the same date and the shortwave infrared channel. And those are the two that are on the top of the layers panel that we're looking at. So, how can we calculate the normalized burn ratio for one set of images, one time period? We'll start with January 6th. So open up the raster calculator with the raster tab and enter the following equation, right? We just saw our normalized burn ratio equation is right here. So we can enter that using the near infrared and shortwave infrared data that we have. So we know that it's NIR minus SWIR. Let's put that in parentheses. And we know that we have to divide it by the NIR plus shortwave infrared. Close parentheses. We can click this Create on the Fly raster instead of writing Layer to Disk option. We can name this layer. Let's name it NBR 0106. Great. Click OK. And we've got something that's popped up for NBR. Now it's all looking like a white blob, but it's probably fine. Let's go ahead and just alter the symbology by right-clicking, going to Properties, Symbology, and just setting the minimum to -1 and the maximum to 1. If we click Apply, click OK, there you go. That looks much more reasonable. And we know that the normalized burn ratio ranges from 0 to 1, since we've read about it beforehand. So we're in good shape here. We've calculated the NBR for January 6th. Let's go ahead and calculate it for January 14th. So we know that it is the NIR channel minus SWIR over NIR plus SWIR. Again, we're going to make this a temporary raster. We're going to call it NBR 0114. And go ahead and click OK. Layer pops up. Same issue with the symbology, which we can correct by right-clicking, going to Properties, changing the min value to -1 and the max value to 1, and clicking Apply. Great. So now we have NBR images, the normalized burn ratio from after the fire on January 14th and before the fire on January 6th. And actually, you know, you can start to get a good sense of what these images might contain as far as information and the story that they might tell, right? Already we can start to see some things pop out if we check on and check off some of these, the two different dates, right? We see some pretty large differences in the NBR. And that's really the ethos behind the normalized burn ratio, or sorry, the difference normalized burn ratio, which is just the subtracting the NBR from after the fire from the NBR before the fire. And this image actually really explains, I think, why this is a good approach and the physics behind it. So take a look at this, but I won't belabor it here since this is a tutorial. But we know that we need dNBR, right, which is the pre-fire NBR minus the post-fire NBR. So let's go ahead and calculate that. We can do that again with the raster calculator. I'm opening it up. So we got the pre-fire NBR, we got the post-fire NBR. We're going to create an on-the-fly raster instead of writing the layer to disk, and we're going to call this the dNBR. So click in OK. And there we have it. Again, we've got our big white blob, which we can fix by changing the symbology to be between -1 and 1. Okay, so there's our dNBR map. And clearly the two fire areas, the Palisades fire and the Eaton fire, do just jump out to us for sure. And if we overlay some of these watersheds really quick, let's see if we can get a sense for what we're dealing with. Let's just make this transparent really quick, and we'll make the outlines red. Great. And click this on. And there are our watersheds, and there's some of our NBR data too. Okay. So now we're essentially looking to understand how much of each of these watersheds falls into the different burn severity categories basically given in this table. Now, this, for whatever reason, is scaled by a factor of 1,000. And we're just going to use the values in this table right here. So essentially, these are our NBR values. These are our NBR categories. So I'm going to simplify these just a little bit. So I'm going to call anything less than 0.1 unburned, and then we'll keep these 4 categories. So we're going to use the reclassify raster by table tool in order to achieve that. And what I mean by that is categorizing our dNBR layer that we've just calculated into burn severity classes. So let's go ahead and do that. And one of the ways to access the reclassify layer tool that I'm mentioning is through the processing toolbox. And that's a really useful search bar, essentially, that one can access by going to View and Panels and Processing Toolbox. You can also get the same effect by right-clicking on some white space and selecting Processing Toolbox. Or, like I said, by going to View, Panels, Processing Toolbox. And this box right here will pop up with all of our processing operations, and we can just search for what we want. And we want reclassify by table. Okay? So what we're going to do is we're going to create another raster from this raster, and we're going to call each of these different burn classes a different integer. In fact, I am just going to pull up the slides from today that I think have this information on them because they're much friendlier and easier on the eyes. And by the way, folks, I should mention everything that I'm doing is contained in screenshots on this slide deck that I am on right now. So here are essentially the DNBR ranges that we would like. Let me just get them in table format because I think they will be friendlier to access. So we can grab that from right here. Excellent. Like I said, everything that we're doing is in this tutorial. And here are our burn classes and DNBR values that we want to input into the reclassify by table the reclassification table. So we're back into QGIS. We've pulled up the reclassify by table tool, and as to set essentially these values into the reclassification table, I'm going to click these three dots, and I'm going to add a couple rows. Now, essentially, each one of these rows is going to be a range of values, and the corresponding value that maps to burn severity in our DNBR classification, given right here that we know from tables like this one. So let's go ahead and do that. So for a minimum, this needs to be like the lowest possible value that we could conceive. So I'm just going to give it lots of -9s. It's a very negative, very small value. And we know that anything less than 0.1 in the DNBR is unburned. So I'm going to give that a 0. Next, we know 0.1 to 0.27 is a low severity burn. So let's give that a value of 1. 0.27 to 0.44 is a moderate low severity. 0.44 to 0.66 is a moderate high. And anything above 0.66, and we're just going to make this a very big number for the maximum, is going to be a very high severity burn. So this is our reclassification table. So what it's going to do is it's going to take values in the DNBR data, and based on the value of the pixel, it will change it to the value that we are giving here in this column. And these integers are essentially a representation of the burn severity that we have ascribed to the DNBR data. So click OK, click Run. It's thinking. And soon we shall see our reclassified raster. So again, it looks like a big white blob. That is okay. We can go to Properties. We can change the min to 0 here. And we can make the max 4, which should be the max value that is allowed for us. If we click Apply and OK, there we go. Now we have some kind of detail in our burn severity area map classification exercise. Right, but we're interested in these watersheds that I can click on like this. And if you see some red dots here, it's something to do with the rendering. I'm not really sure why that is, but there are no watershed lines there. It's due to the rendering, don't worry about that. But we're only interested in the burn severity within our watersheds, right? And in fact, it looks like these two watersheds have a lot of the burned area. This one, Garapito Creek, and this one, Rio Honda. And I'm able to do this with the Identify tool right here, where you can click on a feature in a layer that you've selected, and it will tell you essentially the attribute table preview. So, okay, we're interested in understanding the burn severity in all of these watersheds, knowing that it's only going to be very severe in a few of them. So let's go ahead and clip the raster data to the watershed boundary. Since we have, this whole area of raster satellite images, right? And we only really need to care about this area, and it's going to speed everything up if we just focus on this area. So let's go ahead and clip it. So you want to search for clip in the processing toolbox and select the tool called Clip Raster by Mask Layer in Raster Extraction under GDAL. Okay, so we searched for clip in the processing toolbox, and the tool we want is called Clip Raster by Mask Layer. I suspect we could also get to it here if we go to Raster, Extraction, Clip Raster by Mask Layer. Same tool. There's always lots of ways to do things in GIS. So select that tool. Our input layer is the reclassified raster, which I probably should have renamed, but that's okay for now. We know the mask layer is the watersheds, and we can go ahead and just click Run. Great. So what we see now is a layer, and if I just click off all of the other ones, we can confirm. What we see now is our clipped layer clipped to the extent of the watersheds and with our classified burn severity data. Let's rename this to be a little bit more friendly. So let's call it D burn severity. That makes sense to me. So now we are interested, remember, in understanding what the burn severity is in each of these watersheds. And so there's a number of ways to do this, and like I said, lots of ways to do things in GIS, but I'm going to show you one of them. So the first thing that we are going to do is convert the raster data to a vector layer so we can intersect it with our watersheds. So the tool is called Polygonize. And you want the tool here, Polygonize, parentheses, raster to vector. Again, you can access this through the raster conversion menu. And if you select the raster to be polygonized as burn severity, and I'm going to change the name of the field to create to burn sev, and click Run. We got a little bit of an error message, but I don't think it's anything too much to be worried about. You can see it right here, but you can see that our layer still got written, and we can maybe open up the attribute table to make sure it looks as expected. And basically what it is a shapefile or a vector layer where each polygon is a burn severity class, either 0, 1, 2, or 3, and you group like values together. So you can see that where the values are not 0 are over here and over here. But we've got our vectorized layer. It looks fine. So what we want to do is intersect this layer with our watersheds. Now, if you search for intersection in the processing toolbox and then go to Vector Overlay, select the intersection tool. For the input layer, we want to keep the vectorized layer we just created. And for the overlay layer, we want to select the watersheds layer. I'm also going to select some different fields or columns from the watersheds layer specifically that I want to keep, right? Because we're only really interested in determining for each watershed how much fell into each burn severity class. What area in acres fell into each burn severity class. So I'm just going to keep the names because we don't need any of the other fields in the watersheds data because there were lots of them. So I'm going to do that by selecting from this dialog here, overlay fields to keep. I'm just going to click those three dots. I'm going to click name. I'm going to click OK. Great. And then I think we're ready to run. And this might take a second, right? We're intersecting probably thousands of polygons in the vectorized layer with 15 other polygons in the watersheds layer. So this computation could take some time, and certainly for a larger area, it will take more time. So we can feel good that we clipped our raster data to our study area to speed this thing up. So in the meantime, I'm going to open up Microsoft Office online, which we will use to display some of these results. I believe it is just office.com/create. So I will make a new window and go there. You may need to sign in with your Cal Poly credentials, but essentially I am going to get an Excel spreadsheet ready to accept some data that I'm going to export from QGIS. So my spreadsheet looks ready. Let's see if this is done processing. Just about. Pretty good timing. So, excellent. We see our new layer called intersection. We see our old layers beneath it. One thing we need to do, since we are interested in the total area falling under each burn severity class, is we need to add a column to this intersected layer that captures the area of each polygon. So I'm going to open up the attribute table for this layer. I'm going to open up the field calculator by clicking these little abacuses. And before that, I'm actually going to ensure the units of this layer and make sure that they're in projected units that we can use to correctly calculate areas. The way to do that, to check the coordinate information, right-click the layer, click Properties, go to Information, and then down here, Coordinate Reference System. So this is telling me we're in a projected coordinate system in UTM Zone 11 North, and the units are meters. So that's great. That means we are going to be pretty good at calculating areas. So then let's go ahead and calculate the geometry column that we wanted to. We can either open the attribute table and open the field calculator that way, or you can actually get it from right here in the QGIS menu. So I'm going to click that. So we know that we want a new field called area, and we probably want it in acres. So I'm going to call it area. We'll call it area AC to be consistent with the online screenshots. We know that we want this to be a decimal, a number. And since we want the area in acres, and we know that our units for this layer are in square meters, we have to do a little bit of a unit conversion, right? So let's figure out square meters to acres. Just Googling that, and here's the conversion factor. Great. So I'm going to copy this and go back to the field calculator. And in this expression box, I'm going to type $area, which is telling the computer to calculate the area in units of square meters, which you can preview right here, for each feature in the intersection layer, times the conversion to acres. So that looks pretty good to me. That looks like a reasonable 900 square meters is about 0.22 acres, sure. And I'm going to go ahead and click OK here. We can perhaps verify that our new field was in fact added. It was. I opened the attribute table by right-clicking the layer and opening the attribute table to verify that. Great. Now we're going to export this as an Excel spreadsheet and do some quick statistics in Excel Online. So how do we do that? Right-click the intersection layer, export, save features as. I'm going to put this, and so for format, make sure you select Microsoft Open Office XML spreadsheet from the dropdown. For the file name, I'm going to put this on my desktop and call it wshed burn sev. Sounds good to me. I'm going to click OK. And you can see the little message that we successfully exported this layer. So that's great. And I'm going to go through the Excel calculations in a minute, but I think I'm going to quickly make a nice visualization of our watershed burn severity in order to, make something cool and put it on a map. So here's how I'm going to do that. I'm going to uncheck all of my layers except the burn severity layer. I'm going to right-click it and go to Properties. I'm going to go to Symbology here. I'm going to select Single Band Pseudo Color for the render type. I am then going to change the mode to equal interval and change the number of classes to 4. I guess we can stick with 5. No, let's go with 4. And they map to our integers in our classification scheme, which is great. Now, I'm going to change these colors to be a little bit more visually appealing. So we know that the value of 0 corresponds to a value of not burned. So let's make this totally transparent. So the way I do that is just double-click on this little color box, drag this opacity slider all the way to the left, or you can type in 0 right here. Click OK. And then I'm going to change these other colors to something more evocative of fire. Don't at me because I'm not a designer, but I think I can choose some yellows and reds. We're going to go with that. I'm going to click Apply. And if you click OK, then we've got some pretty decent visualizations for the burn severity in these fires. We can overlay our watersheds if we want. Maybe we make this blue, communicate water. But anyway, I would love to see some production quality maps of this because I think that this is so recent and quite important, and I think some of the effects could be interesting to people. So anyway, that is visualization. I wanted to make this a little bigger, make maybe 0.5. And there we go. So here's our burn severity visualized, with red being the most severe and yellow being the least severe. And we can also kind of fly over here and take a look too. But we know that our ultimate goal is to understand the percentage of each of these watersheds that had a low, medium, and high severity burned area, right? So we just exported this file to Excel. So I'm going to minimize QGIS. You may want to save all of your work if this was a real project. So you could save everything. Oh, we've got one of these stray windows. That is fine. We've got our old conversions. We can X out there. We're back in Excel Online. And again, just to remind you, I got there by going to Office. What was it? Office.com/create. Opened up an Excel workbook. And I'm going to load up the file that we just wrote with QGIS. So I'm going to File, Open Files from this device. Watershed burn sev is the file we just wrote. I'm going to open that. It's going to take a second to upload. Pretty big file, I think. And here's our data, right? Look familiar? Look like the attribute table? So go ahead, and Excel is very smart these days. We're going to create a pivot table, and it's going to suggest to us basically the exact kind of pivot table we want to create. We want the pivot table called, I believe, area acres by name and burn severity, because we want to group these two categories together and understand the total area that falls within each combination of these two categories. So insert pivot table, and this is exactly what we want. Area AC by name and burn sev. So I'm going to click that, double click it, and it pops open this new tab. Right? So this is great. This is basically exactly what we want. Like, we're almost done here. Each of these cells contains the number of acres in each severity class, right? This is the low severity, or sorry, this is unburned, low severity, medium, high, total. And what we want, right, is the percent of each watershed that falls within each of these categories. We know our units are in acres, and we're in good shape to calculate that percent of each watershed pretty easily. So I'm gonna make essentially another table with some formulas that we can populate to calculate what we want. So I'm just going to keep this column as the watershed, and I'll just copy pasta these, drop them in there. There we go. I'm going to call this percent unburned. This is percent low, percent medium, percent high, and then maybe like total percent burned. How about that? And then maybe like a total acres burned, I think is interesting. So, great. Now we're basically set up to do what we want to do. We just have to populate some formulas. So basically, the unburned severity category, let's make these bold, the unburned percent for the Upper Los Angeles River. So we know that the unburned category is this 0 index, this 0 integer. So how do we calculate the percent unburned? Well, we have the number of unburned acres, right? We have the total acres, so the number of unburned acres over the total acres times 100 is the percent unburned. So yeah, in the Upper Los Angeles River watershed, not a ton of burning happened. And in Excel, if you grab the lower right-hand corner of the cell, this little target thingy will pop up. Right? So I just wrote this equation in. This little target will pop up. Come on, target guy. A target should pop up. You can just grab it anyway. But yeah, if you've grabbed it and that target's there, you're applying that same formula basically across all of these cells. So this formula I wrote, B4 over F4 times 100. And if I go down here, B5 over F5 times 100. So that's correct, right? So that's the correctly applying the same formula for the lower San Gabriel River. Now, these are a little specific. So we don't need to be this precise, I think. And we can probably format these to be a little friendlier. So I think you can go to home, and then is it like this one? I think you need to select only the numerical ones. And then we can click this way, and boom, that's nicely formatted. Great. So we can essentially do the same exact thing for the low burn severity area and extrapolate by dragging down. Great, and then maybe we'll also make that better rounded. So you can see here that Garrapido Creek, 15% low severity burn. That is what we expected, right? That's the one that we looked at in QGIS earlier. Medium, kind of, we're basically at plug and chug here, so same kind of thing. So I'm going to do medium over the total times 100 and pull that down to extrapolate. Let's do the same thing for high. Had almost no high severity at all. Very, very small percentages, which, I mean, it could just be a limitation of the method. I mean, it was clearly a very high severity event, so, you know, take it with a grain of salt. Nice, we've made those pretty. Now, total percent burned, we can sum over these three categories from before and sum it up for each watershed. Yeah, and you can see this watershed, 25% burned. Garrapido, that's by Palisades, and then Rio Hondo was by the Eaton Fire. And so total acres, we can actually, you know, compare this to some of the estimates, but, you know, I guess the way you could, I mean, there's lots of ways to calculate this, but I'm just going to do like the percent burned times the total. I guess you have to divide by 100 since we did percent times the total, and that's Rio Hondo, so that's right here. So that's 9,150 acres burned in Rio Hondo for the Eaton Fire. Which is not a great estimate, but I guess not terrible either. I guess you would actually want to sum across. And so for the purposes of the midterm, you're done, basically, right? Like, let me just clarify and say, this table is essentially very similar to what is being asked for, but I'm just going to keep going here and feel a little bit of curiosity. So the Eaton Fire, let's just call this all of the watersheds besides the Garrapido Creek. My Excel. You know what? I'm going to do this in such a stupid, hacky way, but I just want an answer. Equals sum minus this one. So that's 13,240.49, which is not far at all from 14,021. So we can call this like Eaton estimate, Eaton reported. 14,021. And then for, I guess we could just do like estimated Eaton Palisades. And this would be reported. And for Palisades, we're basically just this one. So 20,000. And then we can check out the Palisades fires, acres burned. So this is, let's check the actual source of record here, 23,713. So 23,713. And then like, you know, we can calculate a little error and say minus reported over reported. That's like a nice percent error, and then times 100. So that's like 5% off for Eaton. We can probably do the same thing for Palisades and check that that's correct. And yeah, 15% off for Palisades. And honestly, that's not too bad for monkeying around in GIS for a couple of hours. So there you have it. Here's essentially the percentage of each watershed that was low, medium, and high burned according to the normalized burn ratio and the difference normalized burn ratio from Landsat satellites. We processed it in QGIS, and we took some data out into Excel and got some numbers that were actually pretty damn close to what was reported. So science is real, and with that, this tutorial is done.